I haven't recorded. Yeah, fine. Thanks for reminding me this thing. Yeah, I have started the recording. Someone is telling some other things. Aishwarya, are you able to see the screen now?
Yes.
Okay, okay. Maybe some lagging issue at your network. Okay.
Yeah.
Okay, I'm starting resuming the session again. So the first few things it's totally very basic, so I'm not repeating these things again. So the main things starting from here, relational database and non-relational database. The difference, this is the representation of relational database, the top one. The bottom one is non-relational database. So as I was mentioning some advantages and disadvantages. So when we should use relational database and when we should use non-relational database. Okay, I'll be just telling few of the points, but please go through this thing. What are the difference between relational database and non-relational database? Okay, from web as well. There are various points. I'll be focusing some points over here, and I'll be asking some questions maybe tomorrow with these advantages, or maybe you can get some new point. You can also clear your doubts. Okay. So the first point I just tell over here, one of the advantages things in non-relational database, we can push any kind of key value pair at any time. Key value pair means each of the data is being stored over here as a key value pair. Just like name is a key, this is the value is Ram. So this key value combination I can add anytime over here. It's not a big deal. So it is very fast to update any new records or any new structure or any new key value pair. But over here to add the same thing, it's a bit difficult. We need to update the tabular structure and we need to insert the records. Okay. The second things for the analytics purpose, if we are doing data analytics, so we require the relational database. Okay. So for analytics, suppose we have lots of tables available. Each of the tables is having its own information. We need to merge the thing so that we can go ahead with the analytics part. So their relational database should be helpful one, and we cannot do good analytics things on top of this. Okay, so this is one of the main reason we will be, going forward, we will be doing only relational database, no non-relational database as in the data engineers as of now in our course. But there is definitely some usage as there in non-relational database. Suppose we want to, okay, non-relational database is much more faster. Suppose I want to retrieve some information. Okay, this database is faster than this database. Suppose I'm working in a chat, I'm creating a chat bot. Okay, it's not data analytics things. Maybe on top of data analytics, some company wants to create a chat bot. Maybe, yeah, I found my thing. Suppose I'm a banking, I'm a consumer of a particular banking sector. Okay, so in the back end, someone is doing the data analytics part and all, but in the front end, in the UI side, I'm introducing a chatbot there. Okay, in the chatbot, uh, when I'm typing something, it's fetching the output or it's fetching the reply from some databases quickly to the customers. Okay, to fetch those things very quickly within few seconds or few milliseconds, that is a bit tough for the relational database. So that is why to retrieve any this kind of data from the source systems or just like this kind of non-relational database is very much helpful. But as we are mainly focusing on the database engineering things, we will be doing some analytics part and all. So we'll be especially focusing on relational database from the going forward courses. Okay, I found some more questions. Just let me check. Queries relational database can be used. Yes, definitely we'll be learning these things, especially for the data analytics purpose. We should be using this thing. Okay, and our mainly the thing should be focusing on relational databases only. So gradually we'll be learning what are the different things we'll be learning and what are the different aspects we'll be learning over here. Okay, so Some few things on top of relational databases, some points. So relational databases are also called relational database management system, that is RDBMS. It stores information in tables. So I mentioned it should be tabular format. The tables in the databases shared information between them. There are various tables. They can set up relationship between them. Okay. What is the thing? Let me go to the next slide quickly. Okay. So this is an example of relational databases. Over here, I have stored information of my customers. Suppose I am a owner of a particular shopping outlet. So I'm storing my customers information over here with this form: customer ID, customer's date of birth, their order ID, which particular order they have picked, their address ID, not order, I mean, not the entire address. The ID is only represented over here. Now I want to check in this table, I just put this kind of columns only. Now, suppose I want to check what is the particular address or particular city of this particular customer. The city is not mentioned over here. The city is mentioned in address table. In address table, we are loading the addresses based on each of the address IDs. Suppose address ID 1, this is my address. Address ID 2, this is my address. Okay. So I want to check a particular customer's ID city. I just need to check which is the address ID for this particular customer. I just pick up the address ID from here, and the same thing I need to match over here to check the pin code or particular city for the particular customer. So I need to check two different tables to get this particular details of address. Similar kind of thing. If I just want to get what are the particular details of orders of the customers, I need to go to the order table. I am keeping this order table somewhere inside the same database, and there I am mentioning order ID, product ID, date. Again, we have product table for individual products. Which is the product? What are the product IDs? What are the prices? Okay, so this kind of things I'm storing in product table. But you can see each of the tables is having their relationship, maybe by columns. They have similar kind of columns available. For customer table and order table, we have the common columns called order ID. Based on this order ID, we can set relationship between these two tables, customer table and order table. Based on the common column address ID, we can set relationship between these two tables. Based on the product ID, we can set relationship between product and customer. We just have to set relationship first with this product ID. So we can fetch those tables data, and then again we can compare these things to here, and then we can just have a relationship all between all the tables. So that is why relational database should work. We are keep storing the tables with various subject areas in a same database, but there can be common columns. Why we are separating these things? We can store all the things in a single table, but why we are separating these things? We are keeping small column numbers over here in a single table, and we are transferring the other columns to other tables. Why we are doing these things? That things we'll be learning tomorrow. Okay, we can keep all the things in a single table as well. Suppose I can put customer ID, customer date of birth, then I can put the addresses of the entire and for the particular customers. Then I can put all the, I mean, which particular product that particular customer bought. Okay, so I can pull all the information in a single table, and I can save the same thing. But why we should not do this in a final database? That thing we'll be learning in tomorrow's session. That is called normalization process. So when we'll be storing the data or table in databases, we need to go ahead with particular rules. Why we are going ahead with the rules? Because that thing should be helping us out to retrieve the information very easily from the data warehouse, and that should also help us to do the good analytics part. Okay, and it should also helping us to store the information with efficient way based on, I mean, available space and all. Okay. So that will also consume less space if we are just storing the thing in this manner. Okay. In details, we'll be learning the thing in tomorrow's session, but this is how the relationship maintains between tables. So that is why it's called relational database management system. Okay. The fourth point in the previous slide, a table uses columns to define the informations being stored. That is how I already mentioned it. A columns is defined what is the information of that particular subject areas, and the rows of the rows means the number of records we are inserting. Rows are nothing but the records of that particular table. Okay. Each table will be have a particular column called, okay, each table should be having a column which is unique in nature. Okay. In the next slide, suppose this slide, customer ID for customer table, it should be unique. Okay. Suppose product, in product table, we are just saving the product related information. There, each product I'm putting individual product ID over there. So product ID for this table should be unique. Customer ID for this table should be unique. Order ID for this table should be unique. So for each table, we are keeping one particular column, or maybe there can be set of columns. I'll be coming to this thing later again for the set of columns, how that can be handled. But just to let you know, a particular table should be having few columns or single columns, which should be unique in nature. That can be the row identifier. For the customer ID 123, that cannot be repeated for the entire company. The customer ID is unique. So that particular column is called primary key for that particular table. Yeah, Kamaxi. Yeah. So yeah, definitely. As of now, we'll be starting whenever. I mean, I'll be starting MySQL maybe tomorrow. Okay. So when we'll be learning MySQL, maybe the previous day I'll be telling you how to install it, so that you can install the same in your system. We'll not be using Anaconda, Jupyter. We'll be using directly Python, some IDs and all. So definitely I'll be telling you before the course should be started. I'll be telling you. Okay. Definitely we'll be gradually, I mean, covering these things one by one. So relational database, what I was telling, for relational database, an individual table should be having a primary key, which should be unique in nature. Okay. The same thing for order table, product ID is not a primary key. Maybe in order table, order ID is the primary key. I have suppose order 1, 2, 3 ABCD. It's a alphanumeric code. In that particular order, I can see a particular customer purchase a particular product called ABC. Maybe in another product, another order, a particular customer purchase the same product again. So in order table, product ID cannot be a primary key. Okay. But in product table, we are just storing product related informations there. Suppose I have in my shopping mall, I have ABC product. That ABC product, I'm just pushing them only one product ID. Maybe I have multiple products. Maybe I have 10 shampoos. I mean, suppose I have a shampoo and the same brand, I have 10 shampoos in my stocks in my particular customer. So, but I'll be giving only one ID to that particular product, to that particular brand. So that is why in product table, product ID is unique. Order table, order ID is unique. Customer table, customer ID is unique. Address table, address ID is unique. So those unique columns are called primary key. Okay. Again, I'll be telling what is primary key in tomorrow's session. But just to let you know, primary key generally, while building a particular table, we generally put the primary keys at the beginning of the beginning columns. Just like in customer, you can see the first column is customer ID. This is the primary key. In order table, order ID is the primary key. So mainly we follow this convention. We put the primary keys at the beginning, maybe in within one or two columns, or maybe 1, 2, 3 columns. We are putting the primary keys of that particular table. Okay. The primary key concept I'll be again discussing in tomorrow's session, and this is very, very important thing. So as today it's totally introductory thing. So just to let you know, the primary key will be helping us to set up the relationship. Again, the concept of foreign key will be coming just to set relationship between order and product table. We are having order ID. In the product table, we are having product ID. Those are the primary key for individual table. But the same product ID is present over here. It's not a primary key in order table. Rather, I can say this product ID is the foreign key in order table. Product ID is the primary key in product table. Let me repeat. Product ID is the primary key in the product table, but the same product ID is the foreign key in order table. Okay. So we need to identify what can be a primary key, what can be a foreign key into different tables, so that we can set the relationship between primary key and foreign key. So you can see the relationship between order and product table is based on product ID. The primary key from here, the foreign key from here. So we can set relationship between these two tables. Okay. So let me just go through my previous slide. That is, I told what is primary key, which is consisting the unique value. The column which is storing the unique value, that is called the primary key. Again, the same primary key is represented in another tables foreign key. We are maintaining this primary key foreign key combination to set up relationship between these two tables. Okay. The concept is clear till now for everyone.
Yes. Yeah.
Okay. If anyone is stucking with the concept of foreign key and primary key, definitely we'll be covering some more details in tomorrow's session when we'll be learning normalization. Okay. Just basic things in relational database, this concept, I mean, we are setting relationship between tables with this primary key and foreign key. Okay. Actually, we used to cover the session till this time, as we have started the classes a bit late today. So I'll be just taking 10-15 minutes more time to cover the session for today's. So today it will be a bit delayed, but tomorrow onwards, I'll be trying to cover within 1 hour. Okay. It should be hardly take 10 minutes more to finish today's session. It's totally introduction. So please check it quickly. It's not very tough. It's very simple. Okay. Now to retrieve data from relational database, we will be using SQL. That is also called SQL. Okay. This is one kind of language. It's called structured query language. So we'll be storing the relational databases. I mean those tables in particular relational databases, and while required for analytics purpose or for data retrieving purpose, we have to retrieve the data by SQL query. So this language we need to learn. Okay. So that is called structured query language. This is one of the demonstration. But definitely we'll be learning the thing. We'll be installing a database in our own system and we'll be learning the thing gradually. But just to let you know that SQL is the particular language which will be helping us out for doing queries and fetching data from the relational databases and all. Okay. So there are another databases called non-relational database. In the slide 2, I just showed to you the JSON structures and all. And we are storing non-relational database in key value pair that I mentioned. So over there, we are using not only SQL, that is called NoSQL. Okay. So how we are storing the data there? We are not using SQL over there to fetch the information. We are using NoSQL. So how we are storing the data? Data is been stored in this format. I already told you JSON. There are XML. XML is also NoSQL databases. Okay, I mean not only SQL. So, but there we are storing the data in key value pair. One more advantageous things over here, we can create hierarchy, data hierarchy. Over here you can see first name this, last name this. Okay, but in address, when we are coming for address, we are creating another hierarchy. It's not directly key value. Inside this key, again, I'm generating another curly braces and using another key value. So we are creating an hierarchy over here. So in NoSQL, it's quite advantageous to create a hierarchy, this kind of data set. But in SQL, it's a bit tough because in a column, we just have to mention only one layer. Okay. Just to giving a introduction. The same kind of introduction I'm just giving to you with a different sheet. Suppose over here, if I'm just trying to convert the same thing, suppose first name, last name, address, I'm just trying to put it. First name. So I'm converting this thing in a relational database. Last name, address. So they are storing the data in this manner. If I just try to convert the same thing, they are storing the thing in this manner. Okay, and there should be address. Address one is for okay, street address city. Sorry, let me put street address. City, state. Okay. So this way we are not maintaining a relational database. We just need to maintain a single layer while declaring the column. Okay. So that's why I tried to mention we cannot maintain this way of hierarchical structure. Rather, we can do this way. First name, last name should be two columns. Here I can put street instead of address, I can directly put street address. No need to put this hierarchy. Or I can put this address, the parent one underscore street, the parent one underscore city, the parent one underscore the child one. Now our table is ready. My table structure is ready. I can insert the record. Okay. So this way we cannot maintain hierarchical structure. How we are maintaining NoSQL databases. So this is one of the advantageous thing in NoSQL. Okay. So data can be represented by charts and graphs as well. This is graphical interface of database. Okay. So the data you can see it's a relational database. The similar kind of data I can convert into a graphical database. This is another way of data representation. And this is one of the required one. So when our relational database is ready in data warehouse or data mart, the visualization team should also come under data engineers. So that particular team will do the analysis. They can create those charts and graphs, maybe in Power BI, maybe in ClickSense, maybe in Tableau, maybe in another tools, on another visualization tool they can use these kind of charts and graphs, and those are the final product we need to send to the particular business user to check their sales and all. It's not only sales, there are lots of KPIs. Lots of subject we need to create these things so that their understanding for a particular hidden trend or hidden pattern should be cleared so that they can take their next strategy very quickly. But just to let you know, this is another way of data representation. Okay. Okay, basic example with MS Excel, it is not required as of now. Maybe inside the course, I'll be repeating these things. Yeah, as of now, that's all as the introductory part. In tomorrow's session, I'll be just taking up relational database and I'll be working on top of that. And tomorrow I'll be helping you out to, install a new database in your system. You are correct. MySQL database will be installing in our system. It's an open source tool and we'll be installing this thing and we'll be trying a quick hands-on top of that. Okay. So, uh, from tomorrow onwards or the day after tomorrow, we'll be going at the hands-on part as well. The practical thing we'll be learning as well as we'll be creating tables. We'll be doing the analysis part over here. Okay, so that's all for today's session. Let's connect tomorrow with some more insights on top of data, especially on relational database. So thanks everyone. Bye bye. Let's connect tomorrow.
Thank you.
Yes, Monday to Friday. Rishita. Thanks, Jason.
Thank you.
Thank you. Bye bye.
Thank you.
Thanks.
Thank you. Bye.
Thank you. Bye bye. Yeah, tomorrow we have the class at the same time. Okay.
Thank you.
Yeah. Thank you. Thank you. Bye bye.